Hi guys, today we will be learning about equations of parallel and perpendicular lines. So far you all have been learning about linear functions, so this unit will be a great time for me to see what you know and what you still may need help on. Last time we learned about the slopes of parallel and perpendicular lines, and that will help us with today's lesson. So pause the video and work on the 3 problems, and then I will work through them. So the first problem, the slope of a line that is parallel to the following line, y equals 1 over 3x minus 3. The slope is 1/3 because parallel lines have the same slope. Second problem, find the slope of a line that is perpendicular to the following line, 4x minus 3y equals 12. The slope is m equals negative 3/4, and we can solve for that by first solving for y, which will give us we can do that by subtracting 4x over you have to do what you do to one side to the next. And so then we'll have negative 3y equals 12. And then we can divide by negative 3. Forgot the negative 4x. So that will give us y equals 4/3 x minus 4. And that will give us the slope of 4/3, but in order to have a perpendicular line, we have to have an opposite reciprocal. So then our slope, as I had said, is negative 3/4. So the next question is, what is the slope of a line that is perpendicular to a vertical line? Well, we know that a vertical line looks like this. Vertical lines have undefined slopes. So in order to be perpendicular, the slope would have to be 0 because it will be a horizontal line, and horizontal lines have a slope of 0. So the goal for today is for you guys to be able to write an equation that is perpendicular or parallel to given equations of a line. So refresh from yesterday, parallel lines, if two different lines have the same slope, the lines are parallel, which we did in the bell ringer. For perpendicular lines, remember if the slopes of two lines are m and negative 1 over m, the lines are perpendicular. A negative reciprocal means that it's 1 over the slope and negative. So if you already have negative 1/2, you can do that, but it'll give you 2 as the slope of a perpendicular line. So our first example is write an equation in slope-intercept form that has a y-intercept of negative 5 and is perpendicular to the line y equals negative 2x plus 3. So we know for a perpendicular line, we have to have a slope that is a negative reciprocal of that. So a negative reciprocal will give us 1/2 because the slope in this line is already negative, and we just need 1 over negative, so it cancels and becomes 1/2. So, and it already gives us the y-intercept, so we can just plug that in for b, in slope-intercept form. So that gives us the equation y equals 1/2 x minus 5. So our second example is write an equation in the standard form for a line containing the point 2, 3 and parallel to the following line 3y equals 2x. Well, remember from the first part, we need to solve for our slope. But we're doing it in standard form, which is ax plus by equals c. And so we can just put it in standard form, so we'll have 2x minus 3y equals 0. So that's the standard form of the equation, and we want it to be parallel. So we can stay the same, so we just have to plug in the points to find the new intercept. So we'll have 2 times 2, because we're plugging in our x value here, minus 3 times 3, because that's our y value in our point, and that is equal to 4 minus 9, which is equal to 5. So that will give us the answer 2x minus 3y equals negative 5. Our third example is write an equation in point-slope form for the line that contains the point 4, 5, and that is perpendicular to the line 2x plus 3y equals 7. So first, solve the given equation for y in order to find the slope-intercept of the equation. So we'll have y equals negative 2/3 x plus 7 over 3. We get that by moving 2x to the other side and dividing by 3. Next step, a line with a slope of negative 2/3. Any line with a slope of 3 over 2 is perpendicular to that line because it's the negative reciprocal. Step 3. Since the perpendicular line contains the point 4, 5, we can substitute the coordinates and slope into the point-slope form. And point-slope form, remember, is x1 minus, no, not xy, sorry, excuse me, I'll just write it down for you guys. So it will be y minus y1 equals the slope m x minus x1. And y1 and x1 are our points right here. So we can substitute those points straight in to what we have. So our equation, sorry for blocking that, plugging it into point-slope form gives us y minus 5 equals 3 over 2 times x minus 4. And that's exactly what we have, because we have the slope, this perpendicular slope to that line is 3 over 2, and we just plug in the points directly into point-slope form. How nice is that? Our fourth example is write an equation for the line that contains the point negative 1, 2, and is perpendicular to the line y equals negative x. So first we can start by figuring out the slope, which is easy if you look at this, because what's 1 over 1? It's 1. So we have negative 1, and the negative reciprocal would be cancel out the negative, and so you just have 1. And then plug in the coordinates with the new slope to solve for the intercept b, the y-intercept b. So we can just plug in 2 for y and -1 for x. So we'll have 2 equals 1 times -1 plus b. 1's the slope. And then we can subtract that 1 over, not subtract, add that 1 over because you have to cancel out the negative to get it to the other side. And we'll have b equals 3, giving us the answer y equals x plus 3. I hope you understand that all, because tomorrow we'll be doing an activity and it will have problems very, very similar to this, basically with just different numbers. Have a good day.